Okay, ladies, I'm going to give you the last few examples that we didn't quite get to in class today. And grab your packets and make sure you get to take it down in those notes. All right? So what we have here is a line and a parabola, and what I want you thinking based on that last thing that we did is that there's a possibility that there will be two solutions, one solution, or no solutions. We looked at those, the ways that those would look on a graph. Now we want to look and see what happens when we do these analytically. So remember the basic process is y1 equals y2, all right? y1 equals y2. We note that it is a quadratic because it has an x squared, and that says let's move everything over to one side. I like to keep my x squared positive, so I'm going to subtract x and add 8 to both sides. And there's our quadratic. I'm going to tell you right now that this does not factor. You can try a couple of things and see pretty quickly that nothing's going to work. So we're going to do the quadratic formula. And I'm going to do it without my calculator, okay? So x equals negative b. B is negative 4, so negative b is positive 4, plus or minus the square root of. I suggest you just square b in your head. Negative 4 squared is positive 16, minus 4 times 1. I never leave enough room. 4 times 1 times 6, all over 2 times 1. 4 plus or minus, we want to get that value under the square root there. So 16 minus 4 times 1 times 6 is 24, and 16 minus 24 is negative 8. All right, so here's the kicker. We learned this back in the fall also. When you get the square root of a negative number, that should tell you that there is no solution. So you can either write this answer as a 0 with a slash through it, or you can write no SOL apostrophe N. I want you to try this. I'm not going to pause right here, but you should pause this and try this using your quadratic formula program and look at what it tells you. It's not going to say the square root of negative 8, but it's going to tell you that there's a problem. I want you to look at what it says. Just pause for a second, type your program in, use A as 1, B as negative 4, and C as 6, and take a look at what it says. If we graph this, we would get a parabola, and we would get a line, and they would not intersect anywhere. Okay? All right, we're back from checking that on your calculator. I'm going to look at this next one. This time we have two parabolas, and we're going to set y1 equal to y2. Oh, whoops, I forgot to copy the whole problem. That'll mess me up. Okay, and again, it's a quadratic, so we want to move everything to one side. It doesn't matter which side you move everything to. I have a tendency to like to keep my quadratic term, one with the x squared, positive. But if you look at what's happening on this one, either way you do it, you're going to subtract x squared from both sides, and they just go away. And we end up not with a quadratic, but with something that's just linear. All right, so this thing, because there's no quadratic anymore with that first subtraction, this is only going to have one solution. This is an Algebra 1 level problem, and so a little bit of work on your part, and you should get the answer x equals 8. So only one solution here, not two. And when you get x equals 8, you have to figure out what y equals. Now, we were stumbling a little bit over this in class, so I want to make sure everybody understands. Once you find x, you take x and plug it back into either y1 or y2 if you have time. If you've got plenty of time on your hands, you should do both, because that will give you a check. We'll plug 8 into the first one here. I'm going to do both of them just because I've got a little bit of time now. 8 squared plus 4 times 8 plus 6, 64 plus 48 plus 6. And when you add those two together, you get, let's see, that's 108. So my answer is 8, 108. You should get the same answer if you plug it into y2. If you plug it into y2, you'll get 64 plus whatever 6 times 8 is. Oh, 4 times 8 is not 8, 48. 4 times 8 is 32. Whoops, plus 6. Okay, sorry. If you plug it into the second one right here, you'll get 64 plus 48 minus 10, and it'll give you exactly the same answer. Okay? All right, number 9, we have an absolute value graph, a V shape, and we have a line. We could have one answer, 2 answers, or no answers, but the basic concept is y1 equals y2. Okay? Now, this one has something a little different that we did not see in the fall. So I want to make sure you follow this nice and slowly. Right? First thing is to get rid of anything that's outside the absolute value. So I'm going to add that 5. Okay? Now you don't have to write this down, but remember that if we had worked this problem, the absolute value of 2x minus 6 equals 3, our next step would be to say 2x minus 6 equals plus 4 minus 3. That's how you remove the bars. And that's what we're going to do with this also. We didn't see one like this in the fall, so make sure you're taking careful notes here. I'm going to take the bars off, 2x minus 6, and in their place I'm going to put a plus or a minus on the other side. And when I do that, you need to make sure that you put that x plus 6 in parentheses. You didn't have to do this before because it was a single value, a single number. But now it's an expression. And we need to put the plus or minus on both of them. Now the easiest way to work through this, the simplest, easiest way to keep up with everything is to stop right here and break it up into 2 separate problems. 2x minus 6 equals positive x plus 6. I don't really need to put that plus out there. And the second one is 2x minus 6 equals negative x plus 6. Again, those parentheses need to be there because you have to make everything, this negative has to get applied to both of these terms inside these parentheses. Now, these 2 problems are pretty simple. This problem is not hard, it's just got a lot of steps to it. That's the only thing that makes it feel a little more complicated. But at this point, we now have 2 easy problems to work. 2x minus 6 equals x plus 6. We do a little bit of work. You can take your time and do that. And I get x equals 12 on the first one. And over here on the second one, make sure that that negative applies to the x and to the 6. And again, a little bit of work. I thought it was going to be hard, but when I add 6 to both sides, I get 0, and it turns out that x is equal to 0. I have 2 answers. This is going to have 2 points of intersection. And your job is to figure out what is the y coordinate that goes with each one of those x coordinates. Once again, you've got to do each one of them. So you've got to take that 12 and either put it in y1 or put it in y2. I usually do the easiest one. So that would be y2. And every time that you have chance, every time you have enough time to do it, you should check it in both of them. So doing it in y2, 12 plus 1 is 13. Just a quick check over here. 2 times 12 is 24. Minus 6 is, 24 minus 6 is 18. And 18 minus 5 is 13, the same answer. So there's our answer, 12, 13. That's the point they would intersect in. And then 0, again, plug it in the easiest one first. 0 plus 1 is 1. And if you have time, also plug it in the second one. 2 times 0 is 0. 0 minus 6 here, absolute value of negative 6 is 6. And 6 minus 5 is 1. You should get the same answer in either place. Okay? There are 2 answers. Now, there's a separate video that I had already made, because the other class didn't get to 10, 11, and 12 either. So finish this one up and then go pull up the second video where you get the notes for problems 10, 11, and 12.